1 2 1 1 1
2. Two, two, two. Can you hear me? One, two, three, four.
Test 1 2 2. Ashri, can you raise level, please? Test.
You have a volunteer?
Yes, Victor is
Who? Sorry, who did you say?
He's standing there with the shot.
Test 1 2 2.
And who's doing Jabber? I'll just use their first name.
Test 1 1 2 2 2. Test 1 2.
Yep, small turnout. Yeah, should we start? Jen is here. Did you say you asked her? Why don't you do that and then we'll start. So she'll do the slides. You want to do them right at the beginning? Okay, that's fine. All right, let me start. Welcome to 6-Man. Let's get started. Welcome to Singapore. So here's the note well statement. I'm sure you have all this memorized, and we can take a test afterwards. So here's the administrivia. We have Victor taking minutes and Michael being the Jabber scribe. So thank you very much. Always important. And this is where the presentations are. And blue sheets. Did we do that already?
Yeah, that's it.
Okay, blue sheets are going around. This is the agenda for today. We have we'll do the usual document status, and then we have one working group draft, node requirements. We have 5 active individual drafts, and then 1 new individual draft. So we have a full agenda. We have 2 hours, and at least according to my spreadsheet, it's completely full. So we also just, can you hear me? No, I have to eat the microphone. We also are participating in the NAT64 experiment, and once we get through this, Jen will come up and we have a few slides on that. So I'll turn this over to Oli.
Right, so for the document status for this IETF, we have published no documents. We did quite well for the previous IETF with the IPv6 standards document, so don't feel too bad about that. One document at EISG, that's the MaxRA document. It had a discuss, which we now think is resolved, so that should progress quite quickly, I think. We have 2.5 active working group documents. It's the IPv6 node requirements, which will be we will spend some time on after this. Then segment routing, and then the RS refresh option draft, which is expired. So the chairs will sit down with the authors during this week, and we'll figure out what to do with that. But if anyone has opinions on that document, please jump up and say something now. We also have tried to this time write down some documents of interest to this working group that either we should review or last call in this working group, or at least we should pay attention to. One of them is the extension header filtering going on in OPSEC. There's been discussion on the mailing list on this unique v6 prefix per host. That seems to be resolving itself, I think, so that's probably doesn't require our attention anymore. And then there's a list of segment routing documents that is now about to go to the ISG, I think, which would I think it would be beneficial if we had a closer look at. So if anyone would be interested and volunteer to have a look at these documents with a 6-man hat on, that would be greatly appreciated, and you could send the chairs an email or jump up now. Are there any people in the room that are following Spring, by the way? Okay, COP2? Yeah. Cool. Ron, do you want to do a little bit of a... Cool. Thank you. So we had this one on our... are you saying something, Eric? Yep.
Eric Klein. There's also a document in IPWave that is a survey of IPv6 in vehicle networking things, and it includes a problem statement of what's slow about IPv6 addressing assignment and stuff like that. And so there might be something from there coming to 6-man for us to think about maybe getting RSRA stuff faster. They have a document proposing like vehicle prefix information options and vehicle service options, right? But that document is not yet adopted. Just sort of like a potential document of interest was all. Yeah.
So Krishnan, so 80 for both of the things. So they are more looking at the problems right now. So they're not at any kind of solution level yet, right? Like, so even the problem statement is not done from the working group, but they do have like a grab bag of problems. And like, I think Eric is just giving a heads up that something might come here in the future. Right now, they're just collecting like I would call it like a omnibus collection of issues of like, security issues, like, ND issues and everything for vehicular network. So not in the next 2 meetings, I would venture.
Right, and I don't think we have done this as a very formal process. This is more of a heads up that there might be things that we want to pay a little bit attention to. And yes, Eric, I think we should add. Yep, add that document. So we finished off, getting the core standards off. So that's a done milestone with these 4 documents: 8200, 8201, 3596, and 4443. Then we have 5 documents remaining at the draft standards level that we can consider doing something about or not. Plus then, other documents in that we would consider core to v6 that we also might consider advancing. But Bob and I have done no further considerations on that. We can probably take that to the list, or if someone has strong opinions on what we should do or not do with these documents at this point, feel free to jump up. Eric is not quite jumping. He's he's going to his power code. Yeah. Okay. These were formatted poorly. Jen, do you want to come up?
Hello. Those who been yesterday to V6 Ops probably wouldn't be surprised. So just as an experiment to make sure we eating our own dog food, there shouldn't be no IPv4 in this room for the duration of the session. Please use NAT64 SSIDs. There are 2 of them. One is authenticated, one is not. And there is indeed IPv6 only, which doesn't even have NAT64. So if you're really brave, you can try this one. If accidentally you can see dual stack SSID leaking from other rooms, please don't use it. Let's be honest and try how things are working. If you see something broken, please report it to tickets at meetings.ietf.org. And there will be prizes in the end, just to motivate people to do it. And I think if you can go scroll down to the last slide so people could, yes. Yes, so please use it. It's just 2 hours. I'm pretty sure we can survive without corporate VPN, so you can pay attention to what's going on in the room. Thank you. David?
Hey, David Skenazy, Apple. I just wanted to add from what I saw in V6 Ops yesterday, some people were like, oh, this doesn't work. Well, I don't want to care who stayed on the IETF network. Not only did none of their stuff work because you're too far from the access point, they were also scrambling up the airtime for people in the other room. So please double check on your watch, phone, computer, Dead Badger, that they're all on the right SSID. Thanks.
Yeah, and feel free to run up to the microphone. If something doesn't work, you can just come and scream and we'll solve it straight away, right? We have all the coders for all the relevant products in the room, right? So that should be easy enough. Okay, I think we're done with that. So now we're on the TIMS, the IPv6 node requirements update. Let me just see why this doesn't go in the right. Why is it suddenly small? Wait.
Okay, so we're doing an update of IPv6 node requirements. It's Tim, and John and I are working on updating this document. Go ahead and flip to the next slide. It's got all the just quick context. This will be the third version of this document. That's since its original publication. Excuse me. Okay, so the latest version is 02. It's available, and then I'm going to ask some questions to the room. Please feel free to get up between slides and comment. We found that much more helpful. So the changes we've made since the last IETF. This is a pretty long list. Most of these comments we got either on the list last time we put out this draft, or we had them in the room. So you can see the list here. Some of them are major, some of them are very minor. Obviously, we made RFC references updates to the latest ones. Pretty straightforward, which leads me to the next list of open issues we still have left. Some of these we sent out last week to try to get some early comments, and I'll talk about some of those early comments. We got this comment, was list of changes. Currently, they look just like the list I showed you, which doesn't really give the rationale. A lot of the changes we marked, we said, hey, we updated this, but we didn't explain why. So we'll fix that. We'll put in why we removed things from the list or why we made changes to any of the current stuff in there. Pretty straightforward. This was a pretty big change from the last time we talked. So one of the comments we got, I think from Eric and some other people, was support for RFC 4191. So we added it in here. Now the catch is when you read that RFC, it says you have 3 types of hosts. And we wrote up and said, okay, why don't we say you have to do that RFC, but in this case we said should for type C. The reason we did that was because we thought that was the one that could be the most useful. Obviously there are cases where people will want to do type A and B. I'm sure there are cases where there are constrained nodes, for example, or other reasons you might want to do type A or B, so we didn't make it a must. Everyone okay with that? If no one jumps up at the mic, we're just going to leave it like that. Oh, Mr. Carpenter.
Brian Carpenter. Very quick nit. I mean, it's a nit that's been sitting there. It doesn't actually tell you what type C means in the text. So,
yeah, we have that fixed. Thank you. I meant to mention that. This was another one. So when 8200 was going through, Tom wanted to put in some text about IPv6 extension header processing. And it was suggested by Bob that he put it in the node requirements document. So we got that. It's pretty long. It's about 5 paragraphs worth of stuff. None of it's substantial from the sense there's no must in here. It's a lot of you may do this and you might want to do that and should think about these things. It's pretty long, but especially for this document that is mostly referencing other stuff. But for the most part, I think we're okay with putting it in here unless someone is really opposed to this being in here, and then we'd have to, Tom would have to spin off another draft. It's pretty straightforward stuff. It just explains the order, and if anybody wants to go read that text and send us an email, I'm perfectly happy. I see Fernando's thinking about running at me. Okay.
Fernando Gont. This text you're referring to is the one about the processing of the unknown upper layer headers and so on?
We'll get to that one later.
It's not this one that you are.
No, that's not this one. This one's a slightly different one. Yeah, we'll get to that one in a second. You can throw tomatoes at me in a minute. This came up too, DHCP PD. In this case, we're going to leave it out and not say anything about using it in particular for host at the moment. We don't think there's a wide enough deployment or reason at this moment. If anyone's opposed to that, come back to us, send us a note. We're trying to close out as many of these options as we can now because we think this document's getting pretty close to last working group call. So, all right, here's the other one. Unknown upper layer protocols. So 8200 says there are 3 types: known extension headers, known upper layer protocols, and unknown extension headers. There's also a 4th case that was pointed out on the list for unknown, if you don't know who your upper layer protocol is. They can't be distinguished from unknown extension headers. So this was the proposed text that was put on the list. This is what we're going to add to the draft, basically saying, hey, if you send unknown, unrecognized headers or unrecognized layers, you're going to get back a ICMP parameter problem, code 1. This is really just pointing out what's been there before.
Eric Nordmark, so is that any change? You're just adding words because everybody should have behaved that way for the last 20 years, right?
Yes, and we check this all the time in a lot of the test cases we run at the lab. This is how it actually works.
Yeah. Right, sorry. On the same topic? Yeah. Okay, go ahead.
Brian Carpenter, just to make it clear, that's why this text, which I wrote, starts with note that. It's not news, but it's just pointing out something which may not be immediately obvious unless you think about it.
Bernie Vils. I didn't really read this text, but what happens if there's somebody's asking for this header type that is unknown? Is that going to generate the ICMP message or not? If an upper layer protocol binds and says, I want type X.
Right, that text is in 8200 what to do in that case.
Okay.
And it's the same as this. So it will both do ICMP parameter problem code 1.
Good.
So we've had this request from Fred, I think, since the last IETF about adding a reference to RFC 1122. I'm not a fan of this just because I think that's pretty old, and we can put it in there as an informational reference if people feel super strong about this, but he's the only one who's requested it at this point. I don't know if anybody else feels strongly about this.
Fred Templin from Boeing. I'll just say there's precedences for doing this, like RFC 8200 cites 791 in the first paragraph of the document, and 4861 cites ARP very early on in the document. So for backwards compatibility and for reference to the old protocol, I think that would be appropriate.
Right. So my response to that was none of the previous versions of this document did that. So
that's true.
That's sort of my answer to this, is that the previous, I'm not going to put it in there. The other ones didn't have it. I think we're going to be okay, unless people really have a really good reason for it. I mean, if other people really want to do this, we can. I was sort of going off the previous versions of this document.
I understand, and it just wasn't caught in those previous versions, and now we're just coming to it now. And I just think for the purpose of honoring the legacy in the past that's built the internet, that's why I felt it was necessary.
So just to clarify, the reference to the IPv4 spec in 8200 is for a very particular reason, which is to sort of point to how bits on the wire are sent. So, I mean, it wasn't just added for it was done for that exact reason. And so I'm not sure I understand why we would want to do this here.
Well, RFC 1122 has been the standard for internet hosts for all the hosts we have today on the internet.
Well, IPv4 hosts.
Yeah. But IPv6 builds on that legacy.
Unless we hear from somebody else, we're going to leave it out. Okay, so we've sort of been avoiding this issue as much as humanly possible in this draft, the updating DHCP versus RA options text. we made some minor updates to it, and basically we're leaving it essentially the same. You know, we could obviously expand on this in a lot of different ways. At the moment, we've left it at that, you know, here are the RA options. DHCP is a should. You know, we explain why and, you know, what might you want to do with that. People who care should probably go read this text a little bit closer, but to be completely honest, it's pretty minimal. I don't think there's a whole lot of controversy in there. You know, my preference, I think Tim's preference is, we should probably say a little bit more. My preference would be to avoid this topic altogether, because I think this is more a network operator issue than it is a nodes requirement issue. But I think we said you should do DHCP and explain why.
Suresh Krishnan, I agree with like keeping it minimal, because we tried multiple times before and we cannot seem to agree on what more to say. So I think that's why things are the way they are. So I don't think we'll be successful in a short time in doing more.
Okay. So, you know, people who care about this need to take a look at this text. It is very similar to the last text. We made some minor updates to it to clarify some updated things in the last 7 years. But other than that, we think it's pretty minimal. Okay, so there's a thread on the list about this next topic that. Oh,
sorry, I almost timed out. So that, not this text specifically. I don't know if you're going to address it later, Lorenzo Clearly. There's a should for DHP stateful address assignment. I don't know if that you're going to discuss that later. Or
no, this is the section where you can come talk about that.
So we should say something about the anonymity profile, I think, in the sense that the anonymity profile says that a host that wants anonymity should prefer stateless to stateful, but no RFC allows it to say, I don't want to connect. I never want to do stateful, because there's this should. I mean, basically it says you should do DHCP6. And so the network should, basically what we're saying is the network should be able to ask you to, sorry, what we're saying is that if the network asks you to do DHCP6, you should do it. And the anonymity profile simultaneously says, given the choice, you should prefer stateless over stateful address configuration. So we're kind of saying like you should give up your privacy when asked. And I think, you know, maybe we should have a little bit more nuanced text there.
Suresh Krishnan, just responding to Lorenzo, the network doesn't tell you to do DHCP6. Like, I think that.
Sorry, that's in the text of this document. Sorry, that's in the text of 7844. It says you do stateful. Sorry, if I recall correctly, and we can easily check this, the text of 7844 says whether you do stateful or stateless address auto configuration depends on the MNO bits. That's what I recall from 7844. Somebody can quickly check it, but that's what I recall. And what it says is you're supposed to do what the network tells you to. It also says if you have a choice, prefer stateless. And that's, you know, that's reasonable. But now here we're saying like you should do DHCP6. You should support DHCP6. So it kind of takes away your choice to say like I never want to do stateful because it's bad for privacy. So yeah.
So so Suresh Krishnan again. So I think this is a failure of the working group to specify what the MNO bits mean. It's not that, it's not for lack of trying. Like we did try multiple times to do this. Like I'm not sure what more this document can say, right? So we cannot say like, you know, ignore the M bit because people are going to complain. We cannot say like treat M as 0, people will complain, right? Whatever we say, right? Like,
I have a proposal. What to say?
Okay, go for it.
I propose that we say that if a host is privacy sensitive, we drop the should for DHCP6 stateful. That's my proposal.
I mean,
you have a choice. If you're privacy sensitive, you have a choice not to do DHCP6 address assignment.
well, I mean, there's reasons it's a should, right? This clearly falls into the category. If someone wants to do, you know, that's why they would do it. And so I'm more than happy to put the text in there saying, hey, go read that, go read the anonymity profile for the privacy stuff if you really care about this. You know, we can absolutely put a pointer in there for this.
Suresh Krishnan again. So I think it's too simplistic, Lorenzo, right? Because you could also, if you're privacy sensitive, you can also randomize your MAC address and get a DHCP address, right? For example, I'm just like pointing that out as an example that why this is not simply that. Okay, reading.
No, read it to yourself. Don't read it to the room.
This is 70. You're reading 7084.
7844, yeah.
Okay.
Right. This just points to 4861. I cannot read the whole text. It's a lot of text. But the text in 7844 points to 4861, which doesn't define the flags. So 2461 dead, 4861 decided to not do it.
Yeah.
And right now we are in unspecified state for the flags.
All right. Let me read out the key sentence here. And the key sentence is, when these options enable stateless address auto configuration,
Yeah.
then you should prefer stateless. Yeah. So basically, it doesn't give you the choice to say, I don't want to do stateful addressing. It's basically a should to do stateful addressing if the network tells you to.
I mean, I have two thoughts on this. One of them, this is node requirements. So this is things that will be built in. It doesn't mean that they're going to have them turned on. So we're suggesting that a node isn't going to know what kind of network it's on.
It's like, but you're telling me that I should have a DHCP6 implementation. I don't have one, right?
Yeah, that's what we're saying. That's what we're saying. Right.
Like,
I mean,
but like my point is, it's very much by design for privacy reasons that I don't have one, right?
That's why the should is there, and I have no problem explaining, like, look, the reason this is a should is because of privacy, and go read these documents if you really care about your privacy. Yeah, done.
So Michael Evans, I mean, there's nothing precluding you from having policy and saying, I'm not connecting to networks that don't allow me to do A=1.
Right.
Right. Yes, exactly. But it's like, no. Well, it's a should. That's why it's a should.
Right. Okay.
So last point on this, I don't want to drag this further, but the mbit says, like, if you read it carefully, it says managed address configuration is available. There's nothing telling you to go and do it. Like, so that, correct. Exactly. Okay. Okay. So nobody's telling you to do stateful address configuration. There's like nothing, we have a mechanism to go tell people. The only mechanism we have is to not make addresses available for autoconfig, right? Okay. So that's what I'm saying. I don't see what more we can put in here, but if you have text, like, please talk to Tim.
That's what I'll add, and I'll point to the privacy RFCs, and we'll leave it at that. Okay, so here's a fun topic. So it was suggested this week that we look into, but this is based on the IPv6 hackathon, right? And the general gist here, why this document might care about it, is there are two ways to do some of this NAT64 prefix discovery, also the synthesis of IPv6 addresses. Where it might matter for node requirements is we might want to add some of this into the, if it's coming from the OS, this would be a good place to put it. If we think applications are going to do it, this is obviously not the place to be putting this text. I'm not sure how strongly people feel about this, so I'd like to try to get that part answered.
David Skenazy, Apple. A clarifying question.
Yep.
Can you define what you mean by application? More specifically, a library running in application process space, does that fit as host or as application?
So it's a good question.
Because like when we first started writing those documents, what we had was the socket API.
Yeah.
In this day and age where post sockets and a lot of other efforts, it's not the case anymore. Like on modern operating systems, you can ask for a connection to a host name, and this is done by the OS, but it's still in the application process space. So I think if we want to tackle this question, we need to decide how we define these terms.
Okay. Yeah, I don't have a great answer for that. I think that's something we have to think about a little bit more of how we would box that in.
No, yeah, I wasn't meaning to put you on the spot.
No. It's a good point.
I guess the first thing we need to decide is this something we want to require every V6 host to have in the first place? And if the answer to that is no, well, then don't have to go to the next step.
Yes, this is Alexandru Petrescu. Maybe this is a minority opinion, but I was very much tempted to read this slide and the discussion and the documents when I see the title IPv6 only host. The temptation comes from the fact that I did perform on some tests on a separate environment on what I call IPv6 only host, and these IPv6 only hosts don't have IPv4 on them. Whereas here, it seems like there is still some IPv4, so I think I have a problem on terminology.
So
with
this
IPv6.
case is exactly the one you have in this room right now.
Excuse me?
The case we're talking about here is the exact case you have in this room right now on your laptop, if you connect it to the IETF NAT64 SSID.
Yeah, but I mean on the computer, okay? If you call it IPv6 only host, there is no IPv4 on it.
Go and look on your computer and see if you have IPv4.
Well, I think I do have. Okay. Okay, you mean go on my computer, look if I have an IPv4 address or whether I have an IPv4 stack.
You do not get an IPv6 address and you have no IPv4 reachability in this room right now.
Yeah, but I do have an IPv4 stack.
I don't care what code you have on your laptop, but you have.
So you don't care, but you call it IPv6 only. So why you don't care?
Because we have a terminology issue.
Yeah. Okay. Okay. We have a terminology issue. And there are IPv6 only hosts that don't have IPv4 stacks on them. Okay.
Lee Howard, yeah, as Lorenzo pointed, we have a draft on the terminology in V6 Ops that got torn to shreds yesterday. I'm telling you, there's a vocabulary problem here. So I don't think that we should put this in the nodes requirements document.
Okay.
Because I don't think it should be a requirement. I think there are lots of places where we have V6 only networks that are V6 only. There is no connectivity to anything on V4, and a V6 and a node shouldn't require connectivity to a protocol it's never going to use. Further, I do think that, so further, if we require this of all nodes, even if we were to scope this to all big I internet connected nodes, then we're saying we must always have IPv4 because there's no reason ever to not use IPv4.
This is not IPv4. It does not require an IPv6 stack in the host. Right? This is
what?
Of course not. No. There's no V4 packets on these hosts, right? Run Wireshark on your laptop now. V6 packets.
So two things. If you want to argue the draft, then you should probably do that from here and not there.
Which draft? We don't have a draft.
Which draft? The draft we're discussing.
So
you're defending a proposal that should go about whether it should go in the draft as a working group chair.
Yeah, I can move on. But I'm just clarifying the point that there is no V6 stack required for this function, right?
So there's no V6 stack required?
Sorry, V4 stack. Yes, that was kind of an important.
So, but you're trying to provide connectivity for V4 for applications using V4 literals.
It doesn't require a V4 stack, but it's totally useless unless you have one. So if you do all of this and you don't have a V4 stack, it's useless.
I don't get your point. This is a V6 only node.
Right.
Talking
that may or may not need connectivity to IPv4.
Right, which it gets from an external gateway far, far away from you. Right, which has V4. You don't have V4.
No, it may never need to connect to something far, far away.
That's fine, but you still don't need.
So why require it?
Require what? You don't need a V4 stack. You don't need V4.
I don't know is on third base. We're kind of going around and around in this.
Okay, so can I step, Suresh Krishnan, I'll step in to clarify for Lee, okay? So the DNS64, right, is a man in the middle, okay? And DNSSEC is there to stop man in the middle. So the only way DNSSEC would work with a NAT64 system is if the host can synthesize the quad A by itself. So do we want to do that or not? That's
Right.
the question.
Yeah.
That's it.
Actually, I need more.
Hi, Alan Durant from ICANN, speaking on my own behalf. I have seen a number of presentations from Jeff Houston that shows that DNS over IPv6 and large packet that comes with DNSSEC has a failure rate from anywhere between 20 and 40%.
Yeah.
Well, it's not exactly fixed. From what I understand, you may have fixed it, but the rest of the internet not. I think that requiring every single node to do DNS resolution over IPv6, especially in order to get DNSSEC to work, that comes with very large packets for the signature, is at this point in time not realistic. If you want to break 40%, 20 to 40% of the internet, go ahead, be my guest.
Ole, you asked me earlier, go look on your laptop, see whether you have IPv4. Well, it's a laptop. I looked at the IPv4 IP addresses configured on the interface, and then I see lots of IPv6 addresses, and I also see IPv4 link local addresses.
Right.
Okay, so that's not an IPv6 only host.
Okay.
169 something.
I would. So from my perspective, I would like to avoid
169.254, 176, 163 preferred.
But I think that problem is somewhat orthogonal to this, and
Yes,
probably
that-
one we can do in Sunset 4.
I incorrectly
But
labeled
you're
this
asking
slide.
us to do some tests, and also I want to tell you that the ESSIDs are very hard to connect to. The only one I could connect to is IETF NAT64 unencrypted, because the NAT64 normal one has a problem with certificates. Okay? So I cannot do the test on the ESSID called IETF IPv6 only. Well, even if I wanted to do the test on IETF v6 only.
So just to clarify, I think what we should be talking about, the question is, should we put in node requirements the things that make NAT64 environments like this current Wi-Fi work better?
Yeah.
It's not to define what an IPv6 only host is,
Yes.
which is, seems like what we're talking about.
Right.
Okay.
So before I start speaking, is somebody close to me? Do they have a clue bet that they can hit me with? Okay, so if the clue bet's at the ready. So let me see if I understand, because I didn't before. Regardless of points 1 and 2, what I'm trying to understand the slide. Is it the case that if you want to do DNSSEC validation and you want to work on a DNS64 network, you must support the points above? That's the case, right?
Yeah, that's my understanding.
I guess,
It's
I
easier.
guess Jeff is in the room and can answer with an authoritative answer on that one. But
Like if nobody can answer this question, then we can't proceed, right? Yes. Okay. Good. Right. So then the first two I would say are subservient. I should be made subservient on the third one. If you intend to support DNSSEC on a DNS64 network, you need to do the first two.
you definitely need to do the first two,
Right.
yes.
But
And
if
then
you,
for the third one, it depends if you want to do local validation.
you
or
don't
not.
need to do the first two. That's my assertion. You don't need to do the first two. Like we do them, they do them, but you don't need to do the first two if all you do is connect to host names, right?
Right, but most
if you
hosts-
don't have a v4 stack, you don't want to allow apps to open a v4 socket. If you don't want to connect to v4 literals, you don't need to do the first two ever.
But most hosts run things that do use IPv4 literals.
Today. But if I want to write a new operating system that doesn't support the socket call and doesn't support AFINet, I don't need to do the first two. But if I want to do the third one, then I have to do the first two as well. Fair?
Yeah.
Yeah. So then maybe it should be written like this, right? You don't have to do the first two, but if you want to do DNSSEC, you have to know that it doesn't work on a DNS64 network, and you should support that. Because otherwise, like you've got a DNSSEC, if you say you've got a DNSSEC resolver, and now you can't work on DNS64 networks, which is really bad.
Right.
Does that make more sense? So it's basically like for the last point should be the first one. If you do it, then you have to do all three of these.
Well, it very much is gated on if you think that v4 literals are going to exist or not.
No, we shouldn't require hosts written, like operating systems written 10 years from now to do this. Because if they don't support v4 only apps, it doesn't matter.
Go and talk to the ICE people.
Sure. To the ISPs? No, but like seriously, if I don't want to support v4 literals, or if he turns it off tomorrow, right?
Well, clearly, we're not going to require it. This is not going to be a must, right? This would be text that says, hey, if you want to do this stuff, these are the things you need to do, right? I don't think we're going to make everybody who builds a V6 node write this in.
My name is Chong Feng of China Telecom. This draft is about the requirements of IPv6 node. It seems that right now it mainly focuses on the computer system broadband network. But I think it's better to consider another kind of IPv6 device, that is IoT device. Right now, we have begun to deploy some NB-IoT device by IPv6, but it has different requirements to IPv6 capabilities. For example, sometimes it requires a stable IPv6 address allocation even before its deployment. So I think it is better to cover this kind of device in this draft.
So we have a section that covers, we don't cover LTE. We have a section on 3G that was from the other one, and we made some updates to that. Go ahead, Suresh.
Suresh Krishnan. So, sorry, I'll cut in, okay? So, I think he's more worried about sensors and constrained devices. So, the answer to you is there's other working groups in IETF which do IPv6 over specific constrained devices. So, that's where the profiling, so the smaller set of things is being done. So, if you go to 6LoW or 6Dish or LPWAN, you would see the smaller profiles for constrained nodes. So this is like a generic V6 node requirements. And if you look at a 3GPP node, like Tim says, they have a smaller set of these things, or BBF, right? Like routers will have a smaller set of things. So this is like generically true for V6 nodes, but there could be other conditions which make things more restricted than what's in here. Okay.
I think I'd like to cap the mic line after Barbara there.
Mark Andrews has been, I guess he's not in the queue anymore. Oh, all right. David Skenazy, Apple. So this document is about requirements for IPv6 hosts. And the goal, if my understanding, please correct me if I'm wrong, of this document is that when people who make devices put them on an IPv6 network, they can interoperate. That's what 6MAN does. We define the protocols and we make sure that this is the case. NAT64, DNS64, talking to literal IPv4 host, talking to IPv4 literals is not a requirement to be able to communicate over IPv6 in any way, shape, or form. That's an operational decision. Okay. Like the fact that we at Apple wrote support for doing these things was an operational concern that, yeah, if someone wants to go in Safari and type an IPv4 address, we wanted that to work. But that wasn't a requirement for us to be over IPv6. And we have a working group for that. That's V6 Ops. We have documents for how to do these things. It's chartered for that, and we've actually made progress on documents for exactly these problems. Like Happy Eyeballs version 2 talks about how we do these things. When it comes to DNSSEC, what is this even doing here? Supporting DNS guidance on how DNSSEC and DNS64 interoperate is a great thing to have. I really don't understand why it would be in this document. It's not a requirement for an IPv6 host to do DNSSEC. And even if we're saying, if you want to do DNSSEC, here's how you do it, I really don't understand why it's in this document.
Okay, thanks. Oh, Mark's back.
Red button.
Okay. The reason for having DNSSEC in this document is that if you actually want to look up a quad A address and there's a mapped address that's coming in, it needs to validate. You don't get to connect to the IPv4 server, which doesn't have an IPv6 address, unless DNSSEC actually works, if the zone is signed. So basically, we've got NAT6, or more correctly, DNS64 with NAT64. If you're running a network like that, you're going to have more and more trouble connecting to hosts out there, servers out there on the internet as a whole. At the moment, you don't see it because most people don't actually have signed zones. But as more people sign, more and more lookups will fail until they also have IPv6 turned on. And this thing really should be IPv6 as a IPv4 as a service, and what service elements we need to have into a node, what support in a node we need for IPv4 as a service over IPv6, rather than just one particular mechanism, which is what you're looking at here in terms of NAT 6.4, DNS 6.4.
Yeah. Okay. Thanks, Mark.
Done?
Done.
Okay. Thank you, Barbara Stark. So the way I use the current RFC is every single must that is there must apply to every IPv6 capable node that goes into my home. Every darn one of them. There must not exist a single use case for any device to not do that must. That suggests that this is not a must, because we've already heard a number of use cases where these do not apply. Now, in Broadband Forum, it was mentioned that I have made use of this document by sometimes elevating a should to a must for my particular use case, and that is as it should be. And that's exactly the way I think, should be used, is that when you have a use case where a should becomes a must, then you describe that use case and you describe that in this use case, this should is a must. That was it. Thank you.
Last comment, Michael. Yeah, Michael Abrahamson. Yeah, so are all these musts? So to Barbara's point here, if someone comes up with a device that doesn't do this, then it's violating a must.
I think we're way off. We haven't, we're far off deciding that it should even go in the document, right? So
Right. To be completely honest, I'm guessing if we put it in there, I doubt it would be a must. But
at least from, although I was the one who raised this question, I certainly see no support good enough in the room to put this in the document at this point. We can continue the discussion on the mailing list, but I think we'll leave it at that.
Okay. That's what I got from it too, so I'm with you. So this is the last thing. This document, it was informational, and we're suggesting that maybe we should make it best common practice. Does anyone have strong feelings about this? I think we've talked about this a couple of times, but since we're getting close to working group last call, probably we'll switch it over to best BCP before we submit it, unless people are really opposed to that. All right, sounds good to me. All right, so, I think we got consensus on almost everything we presented today that was up on that list. So I think we're getting close to working group last call.
So I did a little review on it this morning, and I saw there was some gaps still. For example, you had ECN. There was sort of a note saying that you'd get back to it, I think.
Yeah, Tim sent a note about that. I think that stuff we're just going to take out. Is what's happening. Yeah, I'll remove that from the next draft this week. Yeah,
and service discovery perhaps was also a little fluffy around the edges.
Yeah,
yeah,
yeah, yeah. It was. We'll take another look at that section too. Sure. Yeah.
But should we try to get more review in the working group now? Perhaps use the issue tracker to track the last remaining issues, and then could we get a couple of volunteer reviewers for this document? By the way, because it is a 40-page document, it would require some time, but it would be very, very good that we go through this as well as we can, and we avoid any issues later on in the process. Because there's lots of opportunity to get things wrong here.
Yeah.
Yeah. Contact us later if there's no one who's jumping up. Oh, it's me. So who's read this? Who's read this document? It's 4 pages. Thanks, Michael. 3 people. Good. So this is a problem came up where we realized that someone else had taken bits out of the reserved field in the prefix information option in a router advertisement from 4861, and this happened when someone else wanted to have a flag from there, and we realized that we had no central repository over those flags. And the problem was is the X bit that wanted this one. They discovered that in 6275 they'd actually taken another flag out of this this reserved field. So what this draft does is just create a new IANA registry for the set of bits in the reserved field in the prefix information option. Not that we're expecting a lot of use of this, but at least now we have a central place where these flags are defined. So the document does update 4861. It does not update 6275. I mean, the problem here was that 6275 didn't update 4861. And there was a relatively long thread of the correct use of update, and we don't want to rat hole into that one. But this draft, 4 pages, creates a new IANA consideration section, and that's it. It's currently an individual draft. I would like it adopted and you know, last call pretty quickly if we think this is the right way of doing this. Any comments on this one? Lorenzo.
Lorenzo, clearly, does the document need to state that no document can define any ND option without going through this process? Or is that a given by the existence of this document? Because you request that the IANA create this registry. Are you telling the ISG that they have to look at it?
Well, it does say the assignment of new flags in the PIO option header requires standards action or ISG approval.
Okay. And so that would cover, for example, an individual submission?
No.
No? Yes?
ISC, no, but AD sponsored, yes.
Okay. Do we want that to be the case? Can it be added by an informational document?
No.
Yeah.
Yeah, it does. Yeah. So, couple of things. So there is some stuff to be done here for sure, and it's not specifically a problem about this flag. So there's I think some generic work also needed, and it's probably somebody else has to do this. Okay, I'm not like wanting you to do this. I'm fine with this draft, and I'm okay with it going forward. But we have a general issue with updates in the IETF and general issue with flags in the IETF. So like think of it as like, you know, me being a stucky for this to take care of the other things. But yeah, I'm fine going ahead with this.
Right. So I would.
And I really don't think that ISG approval should be the policy for this.
Okay.
So I think like standards action is the right bar.
Only standards action. Yeah. Yeah, I would be happy to change that. No, it does have a general problem in the IETF. What does reserved fields actually mean? And right, and would you need to have IANA registries for all of them before you even started using them? There's a whole, but that's not something 6MAN can resolve. And the only solution we found was doing it this way. I mean, we went through the whole list of should we do an errata, should we do something else?
Right, and one of the things that was brought up when we had this like huge amount of discussions, not in 6MAN, but I think it's on the IETF list or the IESG list, was that if you have a reserved field which says like must be received as 0 and you repurpose it to use for a flag, right? So what happens to implementations that don't read the flag and see it as not 0, right? So that this is a really, really deep rat hole, and I think it needs to get fixed irrespective of what happens with this flag stuff. But I think it's good to start with this one.
But if we do this one this way, you don't see any problems with the IESG. This rat hole will not spin out of control.
I don't think it's going to be an issue. Like we can create an IANA registry at any point, right? But I think the other issues need to get fixed too. Like but yeah. Yep.
Eric Klein, as a co-author of the document that ran into this problem, and I believe I can speak on behalf of my other co-author, As silly as it sounds to have a registry for 8 bits, I approve. I support this work.
Sorry, Michael Evans. So standards action. So if someone comes up with an experimental RFC that wants a flag, then that doesn't go in the registry. So how would we find that if someone else has been using it? Okay. Can you elaborate?
So just to go back into the policy stuff. So like the Suresh answering to Michael. So what I said without the mic. So the standards action will preclude experimental RFCs from taking a bit flag. So if you want experimental stuff to take this, then the action needs to be different. The policy needs to be different. Something else. So it could be.
Well, and the other way to do this would be to now define an experimental bit. But I don't know if we want to do
right,
that.
like IETF consensus could be like another policy which would let you go through the IETF process in whatever way to get it, right? Like could be an experimental. So there's like different policies. I think it's like 80-26 like defines it. Whatever 50-26 bits. I don't know what the number is like by heart, but I think it's 80-26.
Just to make sure, there is a router advertisement flags option produced in 2008. Couldn't that be used for POX instead of reserving a bit in the reserved field? Yeah, so you could have an option in the router advertisement that says the prefix coming after this option, the PIO, is...
But it's a per prefix flag, right? So then it's not trivial to encode it that way. Okay. You could, of course, create a PIO flags extension option, but you can do this in, but I think we'll wait until we're nearly full for that.
Eric Nordmark, yeah, I mean, if you want to do more flexible experiments, you can define another PIO, your experimental PIO, and you can stick 27 million flags to it, or whatever you want to do. And when your experiment is done, maybe you go get one of these bits because you decided it was successful, right?
Yeah.
Do we have a registry for the extended flags, the array flags?
Yes.
We do, okay.
Yeah.
Okay, so it seems like there's support for this, but why don't we do a hum for adopting as a working group document? We'll confirm it afterwards on the list. So if you support this as a working group document, please hum. Not very loud. If you don't support it, hum. Okay, I think we can call that support. We'll confirm on the mailing list. Thank you, Oli.
Thank you. Okay, Fernando, you're next.
Hi. I'm representing a document on recommendations for non-stable IPv6 interface identifiers. As a kind of background, a while ago we did the same kind of work for stable interface identifiers, so that's like a complement to that other work. Let's first start with some background information on this document. There are a number of issues in RFC 4941 that we tried to address in this document. The first one is that, according to RFC 4941, it prevents the use of only temporary addresses. Temporary addresses are employed in addition to the stable ones. There's another thing that, according to 4941, the same interface ID is employed for multiple prefixes. So, for example, if on the same local network multiple prefixes are announced, all of them will be used in the same interface ID, which obviously allows for the correlation of network activity. Another thing is that these interface identifiers are generated over time, and there are implementations, actually that's what the spec says, that they move from one network to another, and they still use the same interface identifier. So it's generated over time. So you generate one identifier now, you employ it for the local network, your node moves from one network to another, and you still use the same interface identifier, okay? So that allows for the correlation of network activity, even when you move from one network to another. Other things is, according to 4941, there are limits on the number of non-deprecated addresses, meaning that at any point in time, you should only be using one temporary address. That's a limitation. And we, well, there are other minor issues in the document. These are the main ones. So what we try to do in this document, first of all, we try to do something similar to what we did with stable addresses, which is start with security and privacy requirements for the temporary addresses. What are the properties that these addresses should have? Then suggest some possible algorithms. These algorithms are not mandatory, so you can do your own way. This is just if you don't have a better option, you can pick one of these algorithms to comply with the requirements. Third thing is to clarify that temporary addresses only are allowed. So far, at this point in time, if you generate temporary addresses, you are also required to configure stable addresses. So what we want this document to do is to say that it's also okay if you only want to use temporary addresses. And the last bit is something that we talked among the authors. How this document would fit with 4941. And the conclusion that we got to that is probably the better option is to have this document obsolete 4941. The reason being the issues that were mentioned in the previous slide. Okay. As a kind of summary of the requirements for these non-stable or temporary interface IDs is that obviously they have to have a limited lifetime. Obviously, they are temporary. We also know that lifetime must be reduced or further reduced by security meaningful events. This could be like moving from one network to another, meaning that the case that I mentioned before in which you generate a random interface identifier and you move from one network to another would make, for example, the interface ID to change. And obviously there are a number of issues here that, or not issues, there are a number of other security sensible events that might trigger the regeneration of interface identifiers. The other thing is that they must be different for different prefixes. So let's say if two prefixes are announced on the same network, you shouldn't use the same interface ID because otherwise it's possible to correlate network activity between those two prefixes. They must not embed layer 2 addresses. They must be difficult to predict by an outside entity or party. That obviously you don't want these IDs to be predictable. And the last one is that they must be semantically opaque. That's obviously based on current standards. What we mentioned for non-stable interface IDs for algorithms, well, first one is just get a random number. You use whatever algorithm you have for generating random numbers. Another possibility could be the use of an expression that is similar to the one that we use in 7217 for stable addresses. It just has like a minor modification. First, we have a time value over there so that they do change over time. And in this particular case, what we did is we also include the MAC address. So in 7217, this is let's say an abstract parameter, which is the network interface. But in this case, we include the MAC address because we want to make sure that if you are randomizing the MAC addresses, well, when you change or you randomize a new MAC address, also the interface IDs for IPv6 addresses change. So I don't know if there are any comments.
Yes. When changing the interface ID upon connection-reconnection event, one should be careful because the connection-reconnection could happen in the same ESSID or in the same cellular SGW if you want. Okay, so basically you want to avoid the situation where you keep the same IID when moving from one network to another. But if you say connection-reconnection, the connection-reconnection very often happens in the same network.
Yeah, one way to do that, which is, for example, what we do in one of the, the algorithms, is that you can tie the randomized interface identifier, for example, with a MAC address. And in the case that you assume that the nodes are randomized in the MAC addresses, if you go back.
Which MAC address? My MAC address or network?
Your MAC address. And in that case, if we assume that the node is, for example, randomizing the MAC address, well, this problem is actually tied to what the node does about MAC addresses. If you are doing MAC address randomization, when you actually connect to a different network, your MAC address should be changing, and if the MAC address changes, you should also change the IPv6 address. But
and if you don't do this MAC address randomization,
I mean, obviously, that's for the node to decide, because it's hard to tell.
I mean, you can put a MAC address that I want, but I don't want it to be random.
Sorry?
Okay, yeah, we can discuss the mechanism separately.
Okay.
Lorenzo Colletti, clarifying question. Is the algorithm used, suppose that you only have one global prefix.
Suppose you only have one?
Suppose you only have one prefix.
Yeah.
Is the algorithm currently specified by 4941 allowed or disallowed by this document?
Well, the thing is, there are, if you look at 4941, there are things like, for example, even if you had a single prefix, there are lots of things that you should patch in 4941. Example, you generate the random interface identifier, but over time. You generated one random identifier now, you move to a different network, you reuse the same random identifier. So what we were talking with our co-authors is that if you were actually to try to fix the issues that we found in 4941, I mean, the document would be, you would end up patching the document in so many different places that it doesn't make sense. So you could say that you might try to do improvements to 4941, but at the time that you try to address the issues that are described here, the patches would be so many that I would probably move away from that algorithm.
The reason I ask is that there's a lot of stuff in 4941 that is now going to be deleted if you deprecate it. For example, it tells you how to generate new addresses if you get a DAD failure, right? All that stuff is in there, and it was, it's operationally proven, right? So, I don't know that we want to throw it out completely.
That's something that we talked among the co-authors, and there are possible ways forward for that. I mean, the thing is that if you want to keep 4941 as an option, there's still lots of things in the document that should be patched. I'm not saying that, that's not a possible way forward. Or we thought that, I'm not sure it makes sense to do that.
Okay. So another alternative to resolve this might be, instead of doing this as a separate document, is to move the work to do a BIS document for 4941 and just change what we want.
The thing is that when we considered that option, is it couldn't really be a BIS document. On 4941, if you look at the issues that we mentioned here, among other things, like 4941 sticks to a single algorithm, and we don't think that you should do that. What we think is that what you should do...
So the BIS document would change that.
But a BIS document, isn't it supposed to be like an improved version of the same thing?
Not necessarily. I mean, if we want to change the way this stuff works, then we can update it. I mean, we're not going to, if it's a bunch of new things, we're not going to advance it to internet standard, but it can still cycle at its current status.
So what would be, let's say, if you were to go on the path of doing a 4941 BIS, what would be different with respect to this document? I mean, besides the fact that the document is not called 4941 BIS, obviously.
Well, we just heard that there's other things in 4941 that would be lost if we just obsolete 4941.
Among we co-authors, I mean, there's a lot of what's in. I mean, there's a lot of details about the generation of addresses that that we might keep regarding timing and so on. But what we kind of think and talk with the co-authors is that at the time you try to address the issues that we have here, the changes would be rather fundamental to 4941. So there wouldn't be much of a difference, like starting from scratch.
Suresh Krishnan, 80 hat on and 4941 hat off, right? Specifically want to say something. So 4941 is a product of this working group or something that preceded it, right? And that was done at a time where the internet environment is different. Okay, so we didn't have this pervasive monitoring, we didn't have this kind of tracking and everything. So it was done to a different set of things. And I think it's the working group's job to maintain its specifications. So, and I do understand what I see, like, but I see this as like 6 of one and half a dozen of another. Okay, like either 6 of one, half a dozen of other. It's like the same thing. So either you take 4941 and fix it, or start this and you're going to pull in some stuff from 4941. It's going to be the same end result. So the working group needs to decide which way it needs to go. And if the working group decides that 4941 BIS is the way to go, right, is the way to do it, and the content of 4941 BIS is whatever the working group decides it should be, right? And at some point, you need to think about backup compatibility, right? Like, what happens to nodes, like what happens to, like, because it's on one node, there's no like interrupt issues really, right? Like, well, how you generate an address, like you don't have much interrupt issues. So that's like a good thing, right? Yes, right. Okay, so Lorenzo disagrees, but like, okay, probably, okay. So I think this is not a technical decision. So you talk as if there is like a big technical difference between 49 and 41 BIS and this, but I think it's not. Whatever document we're going to end up with, right? Whatever is the ideal document, right? With the new multiple algorithm support and everything, can either be called 49 and 41 BIS or something else, right? And I think that's the working group's decision, how that goes. So that I'll support whatever the working group does, right? Does that make sense? Like, what I'm saying is it's not a technical decision, because you say like, 49 and 41 has one algorithm. Of course it does, right? But doesn't mean 49 and 41 BIS needs to have one algorithm. That's the point I was trying to make.
The part that I don't follow is when you say that another option is to do 49, 41 BIS. So what I'm trying to figure out is what in practice that means, like 49, 41 BIS.
Okay, there's a bunch of things in 49 and 41, right?
Yeah.
Okay, so there's some things that's in this draft, some things that need to get added. Okay, if you take whatever document you take as base, you take 4941, it's not ideal. You take your document, it's not ideal. They both need, it's not ideal, right?
Well, it will never be.
No, but like, Lorenzo just brought up something, right? Like, DAD failure, like you keep regenerating, right? That's missing. So at whatever you start off with, you need to improve it. What the document is called is not material, personally, for me.
Yeah.
Right? And as I said, if the working group decides to take that up, right? Like they need to, I really want that to obsolete 4941, period, right? Like if we decide like 4941 is not good enough for the environment of today, we need to obsolete it and better be a BIS, right? That's all I'm saying, right? Like, so this is with no hat on, right? It's like, it's the right thing to do, is to just BIS it and obsolete the old one.
Part of what this document tries to do is to up-level things a bit. If you go, for example, what was it, 8064, they want the requirements for stable addresses. What that document does is specify requirements for stable addresses. And then you get, for example, in that case, it's in a different document, to find algorithms or possible algorithms that can comply with those requirements. So in a sense, I mean, this document does contain some sample algorithms, but at the end of the day, it's a version or something similar to 8064, but for non-stable addresses. I mean, for example, the algorithms themselves could be moved out of the document. I'm not saying that that's our plan, but say it could. So this document in that sense is the equivalent to 8064, but for temporary addresses, like set requirements. Then how you actually comply those requirements, for example, it could be something like along the lines of 4941 if, it's patched to address these issues.
Okay, I understand what you're saying, but that's not what's in the draft. So I'm only talking about what's in the draft, right? Like, so if what you say is like, you're going to set down the requirements, I'm perfectly fine with it. But that's not. So I think
the document right now does both. And actually, what we have right now is on one hand, actually, there was a version that, we didn't get to post. But what we do right now in the document is specify the set of requirements and then say, if you want to, let's say, comply with these requirements, then these are possibilities. Like, I think that in the version that is posted right now, we even have 4941 as one of the possible algorithms, modulo addressing the things that we have here, okay? So it's listed as one of the possible algorithms, and that's something that we were discussing among co-authors, like what to do. So let's say one possibility was to, for example, mention a couple of algorithms and then also point to a patched version of 4941.
Okay.
Another option was to include all the possible algorithms in there. I mean, that's open for input.
That's good. As long as you clarify, I think like I would be okay with it personally. But it was, I think, like mixing of all these things into the draft confused me personally, right? Like, but if you separate it out, I don't see like an issue.
I mean, it's this is open for input. Like I understand that the working group might say, well, it is okay to specify the requirements, but we want to do the algorithms elsewhere. That's a possibility too.
Lorenzo, I think we're probably going to end up in a better place if we rev 4941. And if we rev 4941, fix the bugs, and then we generalize that. Because it's good. There's a lot of good stuff inside 4941. It says like how do you periodically generate them, how often you have to change them, the fact that you have to keep the old ones around. All that stuff is really valuable. It's very important to keep, and we shouldn't like throw that out just because it's old. Yeah, there's bugs. It says like use whatever RC4. Okay, that's obsolete. It says or whatever it is. Like you know, but like it's you know. So we should fix it, and then if we want to do something more, is like do something more general. Personally, like I feel like the idea is up to the host. Period. Like that's what you do, right? But then we also have to say, well, don't do something dumb like always pick one. Don't do something dumb like seed your random number generator with the time at which you join the network, because then I can predict everything if I guess properly, right? So these things, you know, I think we're better off doing 4941 bis and then generalizing it. If we don't do it that way, then we have to be very careful and say that one of the goals of this exercise is to ensure that everything that 4941 does today will still be done in an implementation of this new document. So either way, like Suresh said, either way, but we do need to keep that stuff around.
How do you?
Okay, so we're really over time. So why don't we get the other two people?
There's another thing that I wanted to say, which is, we should absolutely change the words should not embed link layer identifiers to should not embed stable link layer identifiers. The plan of record is for us that we will use EUI64 addresses with dynamic MAC addresses.
So you want to waste
yes, that is the plan of record. Well, because it gives us camouflage benefits. We pretend to be an old legacy host.
Well, for me, that's flawed.
Sure, that's fine. But
Okay.
we are going to disagree on that. And so my opinion is that we should change that text.
So you have a document that is supposed to prevent tracking. So the more random the address
Fernando,
is, the better.
We're not going to have that argument now.
Listen
Okay.
to the comments. We don't have time to.
Eric Vink. Just a quick comment in the same vein as Lorenzo. There are some texts in the current draft, and they say network connect, disconnect. It's a kind of unclear. Do you think it's a node that go in sleeping mode and quit the sleeping mode? Is it a new connect? If so, I'm a little bit concerned that we end up with too many addresses, because that's nice for the host, but for the routers is a cache. And in some case, for security, we keep a lot of state.
That's a good point.
Eric Klein, I was actually going to say the same thing Eric Finke just said. And there's a deployment section in 4941, which, as we discovered, as it was made known to me in V6 Ops, section 3.6 says you must be able to disable these privacy addresses, which I think we should It's we should make that a should. And one of the things that you can include if you revise, if you do a 4941 bis, you can rewrite the deployment section to be more sane and include things like, if you don't have the whole /5040 yourself, then be careful you don't flip over into promiscuous mode and stuff like that.
Mm-hmm.
Okay, super. Thank you, Fernando. I think you can still stand in place. Address usage.
Yeah. So this is a document that we presented at the last IETF meeting. Essentially, this document tried to discuss issues that you find when you try to leverage the use of IPv6 addresses. And at that point in time, we tried to have the document also provide solutions for that. Let's try to do a brief summary of this document or the problem statement. Essentially, when you have a V6 node, you have multiple addresses of, different properties like scope, stability, and so on. And first, on one hand, that at times the implications of the difference in these properties or which addresses you use for what are not well understood. And also there are limitations in the APIs when it comes to how you can leverage the addresses that you have on your node. Example, for For example, what we have right now regarding the API when you want to perform outgoing connections is that essentially you rely on the default address selection, but there's no, it's not really possible to, for example, specify what kind of properties you want for the addresses. Example, if you might want to use a different address for something, could be a different user, different subsystem, a different whatever that is. You might also, I'm not saying that is something that we're pushing or recommending, but for example, if you want to use a new address for a new connection or product or a processor, whatever that is, it's not possible to actually have, it's not possible to actually achieve that. Implications of that limitation is that obviously, the more you use an address, of course, that allows for correlation of network activity. So that's when it comes to outgoing connections. Then when it comes to incoming connections, there are other problems. Like, for example, right now it's not possible to specify what are the properties that you want for the addresses on which you listen for incoming connections. The typical practice is that when you are coding an application, essentially, you use the wildcard address in bind, meaning that any address that is configured on the local node can accept incoming connections. There are a number of issues for that. For example, one of the possible issues is that you might be running some sort of service that is meant to be, for example, to be employed or used only on the local link. And obviously, if you bind your socket to the wildcard address, then that service becomes exposed, if you have a public address, to the public internet. And then there are other things, and this is something that, don't remember the name of the guy, but it was something that was discovered in the wild, in which, let's say that you have a device and it has temporary addresses. Well, it was found in the wild that this device connects to the internet. It employs some kind of like service, but when you employ that service, then that exposes one of your addresses, right? Now, the same address, the same temporary address that you use for performing an outgoing connection can now be employed to contact you. So in this particular case, I don't know if you have read about it, but it was a Raspbian system. It was connecting to a ROG NTP server. And right after, using NTP, they were getting a port scan by, because this ROG server was actually employing the temporary address for that. Since it's not possible to actually, specify the properties that you want for these addresses, even less in a portable way, well, these are some of the implications, or some of the security implications that we have. In the previous versions of this document, we tried to, or we were meaning to provide advice in this area. This was more of a to-do thing in the document. And based on the discussion that we had at the last IETF meeting, we agreed on having the document just focus on a problem statement, like limitations that we have right now, in the hopes of actually, first of all, raising awareness, for example, about the implications of the properties in IPv6 addresses, but also possibly trigger work that, might mitigate these issues. So the document right now is actually, despite the file name, we changed the title because it's a problem statement. So we are not proposing anything specific here, but just describing the problem so that in the hopes of, subsequent documents could actually address these problems. So I don't know if people have read this document and have questions, comments.
How many people have read it? Hand in the air. One person. I read it. So two, three. Have you? So last IETF we had, I think we had two discussions. One was that we didn't do APIs, and David Taylor, who is the liaison for the for POSIX, I guess, suggested you two should sit down and discuss, how to do it with the API. I guess that's where it moved to a problem statement. The other discussion we had was, this likely belongs in transport, and there's certainly quite a lot on work in transport right now on APIs, post sockets, and things where these considerations belong. Have you presented this in transport, or have you only?
I didn't. Regarding the APIs, what what we did talk with Dave, and the thing is that we don't get to specify like APIs for specific languages, but we do get to specify abstract APIs. So what we were talking with Dave was that, I mean, this is not in this document because this document is not meant to specify anything, but what we talked with Dave, but I don't know if Dave is here, but I mean, I will let him make his comment, but it could be possible to do like the specification of an abstract API, and then that could be like forwarded or try to be taken to other groups there where they might specify like a language-specific API. Those language-specific APIs are certainly outside of the scope, but we could actually work on an abstract API. Like, if you want to specify a language-specific one, well, what are the functions and the calls that you should be supporting?
And with regards to the transport area, you have not been there.
I didn't present there, no idea. Personally, I think that I think it belongs to the internet area, but that's just my personal feeling. But I haven't talked to anybody in transport, haven't presented it in transport, so that's as much as I can say.
So perhaps Bob and I should take an action and have a chat with the chairs of TAPS, I guess would be the most relevant one. Please.
George from APNIC. So I want to see if I understand what I think I heard you say. I want to do NTP, and I want to have a way in the API to request an immediate ephemeral address that I use to originate packets to an NTP server and get a response. And over in a different daemon on my Unix host, I have a v6 SSH daemon that is listening on any address, and I want that not to respond to that ephemeral address that I used to do NTP, because I didn't want the NTP to expose my inbound path on SSH to an inbound risk. I did not wish to respond or be discovered. And you don't want to use packet filtering in the kernel, and you don't want to use external protections provided by the ISP restricting flows. You want to have an API flag that says, when I said any address, I meant any address except the ephemeral address, for instance. You want to have conditional flags around the binding qualities for listening and for sending. That's what I think I'm hearing you say.
That's one of the possibilities. We are actually talking about like a more general case. Like
right, a general model to provide for this kind of conditionality around sending and listening to separate the behaviors.
Yeah.
So why would that be here?
Because it's, why not?
Well, because it's an application binding problem. It's up in the stack.
Yeah, but it's there's a lack of an API. So your application is going to use an API for that. There's not an API for that.
There's a set sock API that does something very similar.
Right, so you want to be where the set sock API is defining the behavior.
Suresh Krishnan. So like, I kind of agree with George there, because there is like historical precedent, like because the socket API was done here, but I agree with you that it has to go somewhere else. And I think the right place is TAPS, personally.
Okay, so yes, so let's, I think Bob and I will take that action, and we'll involve the ADs and figure out where this would best belong. Thank you. Fred, you're up next. Please raise the microphone. So you can...
Okay, so this is a document called Route Information Options in Neighbor Discovery Messages. So the document was first posted on the 6-man list in January. List comments resulted in an update to the draft and was presented at IETF 98. We had some more comments that resulted in a new draft version presented at IETF 99. And then there were updates after IETF 99 for draft-05, which is the current version. Here's the pointer to the draft. So the motivation for this work is for neighbors to be able to share routing information with each other on very large links with as many nodes. For example, NBMA. So we want to be able to support direct neighbor-to-neighbor communications at layer 3 without having to go through a router on the link. And we need a route discovery mechanism on links where traditional routing protocols are impractical, for example, due to the large scale. And the solution that we're looking at is to include route information options in IPv6 neighbor discovery messages. So route information options in 4191 were specified to be included in router advertisement messages. And they're to inform the recipient of more specific routes that are reachable via this router. RFC 4191 defines 3 different host types, A, B, and C. Types A and B both ignore the RIOs. Type C process RIOs only in RA messages. And what our draft is doing is defining a new type of host, a type D host, that has the same behavior as type C, except that also processes RIOs in other IPv6 neighbor discovery messages. And this is especially useful for hosts that receive prefix delegations for tethering or multi-addressing purposes. And we have related drafts that talk about those cases. So this draft is updating RFC 4199 to include RIOs in any IPv6 neighbor discovery message. It also updates RFC 4191 to include a solicit bit in the RIO header. So nodes include RIOs in neighbor solicitation, router solicitation messages with S set to 1 to solicit routes from neighbors. And nodes include RIOs in neighbor solicitation, router solicitation, neighbor advertisement, router advertisement with S equals 0 to assert routes. That's saying this is a route that I have and I'm asserting that to you that this is my route. Routers include RIOs and redirect messages with S equals 0 to refer to other routers. So if you have a source, a router, and a target, and the source needs to go through the router to get to the target, the router can send a redirect message to the source that says, you can go talk to this other guy directly without having to go through me. It's backwards compatible in that types A, B hosts will still ignore the RIOs and neighbor discovery messages. Type C hosts will process the RIOs and router advertisements and ignore them in all other neighbor discovery messages. And type D hosts process RIOs in all IPv6 neighbor discovery messages and honor the S bit as discussed above. Some use cases that we're looking at, for example, the IETF conference or hotel or airport Wi-Fi networks where we have large number of nodes that receive prefix delegations. Enterprise mobile devices like cell phones and tablets that connect to the enterprise via VPNs. Aeronautical communications for airplanes and air traffic control, etc. Unmanned air system networks for vehicle-to-vehicle communications, and home networks with multiple subnets, as discussed in the home net working group. And that's what we have. So those are the changes since IETF 99, and we now like to consider making this a working group document.
So Fred, if you go back to slide -05, yeah, one more, there, yes. So I read this the draft last night, and I did actually come around a bit and think it wasn't a, it was quite a good idea. What I couldn't quite get was what's the purpose of the S flag and combined with putting this in other messages? I mean, could you just get away with doing it in the redirect and nowhere else?
So the way the protocol works is that when a redirect message goes back to the source, the redirect is going to be saying, go talk to the target. And then the source is going to send a neighbor solicitation message to the target with that S bit set to 1 that says, I want you to give me this route that you're holding. And then the target sends back a neighbor advertisement with an RIO with S bit set to 0 that says, I assert this route. And you can trust it because the router told you that I'm the holder of this route.
But so how, I don't quite understand how that's different from the main router that you trust told you that I have a routing entry pointing all this prefix to node C.
Right.
Why do you get a benefit from from going to node C and asking him, do you actually have this route?
Right. Two things. First of all, the router has no knowledge of the prefix lifetime of the target. So that it doesn't have any way of telling the source that this is the prefix lifetime. So the source has to go to the target to get that prefix lifetime. And the other thing is the NSNA tests the forward path to make sure the forward path is working before you start sending data packets.
Right. But I could claim that the node you're asking probably doesn't know the prefix lifetime either.
Well, he's the holder of the prefix, so he should know.
But could he actually, and he can just do unsolicited DNAs, presumably, if anything changed on the target node, right?
Unsolicited NAs could also include the route information options, yes.
Yeah. Brian.
Brian Carpenter, could you go to the next to the last slide? That should, yeah. So you said at the beginning the motivation was very large NBMA networks, if I got that right.
Yeah.
Yeah. But can you tell us, apart from the Wi-Fi example, which is not really NBMA because they mostly emulate multicast, incidentally, there's someone on this network who's putting out IP version 4 broadcasts to 255.255.255.255, although it's an IPv6 only network. Can you explain a little bit more what the scale is on the truly NBMA ones and what technology you're talking about? Because I'm a little bit confused about the use cases.
Well, just taken, for example, on this use case with the aeronautical communications, we're talking about having all the airplanes worldwide connected to an NBMA link, and the airplanes need to share prefix information with each other over that NBMA link. So in terms of scale, thousands of nodes, tens of thousands of nodes, as many as you like.
Yeah, but would you really want to put them in the same IPv6 prefix, which is what it sounds like you're...
Oh, no, not the same IPv6 prefix. Each node gets its own prefix through prefix delegation.
Yeah, so we have a solution to that. It's called routing. I'm just a little bit confused about why this is any better than just routing.
It's not practical with that many nodes on the link to run a routing protocol between all the nodes, and that was the motivation part.
Yeah, well, I don't know. I'm not convinced. But I'm not a hardware designer or a technology designer, so I'd better shut up.
But I guess what you do, since this is kind of on-demand creating route to neighbor shapes, you could imagine that, after the first redirect, you did actually do a, RIP request instead of using neighbor discovery for that matter, right? That would also achieve the same.
Right. It's an on-demand system. Yeah.
So, Eric, not Mike. So I'm a bit concerned about the security implications of this.
Right.
So right now, I mean, we have RA Guard as a tool that prevents people from injecting any default routes and any more specifics, right? And the other tool we have is that the way redirect works, it's actually quite constrained, or the validation means that if I'm a host, the only redirect I will trust is one that comes from a source address that's my current next hop for that thing that gets redirected, and it's limited to /128. And here, without going into the potential utility of this stuff, it seems like it's opening Pandora's box that anybody could inject any route for anything independent of who I'm trying to talk to, which sounds very scary.
No, it's
so that's why I don't understand how we could do something useful in this space without saying, oh, we need to run a full routing protocol with its full security mechanisms, whatever they will be.
Just responding to that, the router that's trusted by the source and the target is the one that sends the redirect, and so only the router can assert a prefix that'll be trusted by everyone. And any other node that tries to assert a prefix without having gone through the router isn't going to be listened to. So the router.
But I thought you said I can send it on an NA.
Yeah. So. Yes, that's right. But the NA message is only going to be confirming what the router told the source in the first place. The redirect tells the source, you can trust that this guy over here is the holder of the prefix. And when that target sends back an NA, the source will accept it because the router was the one that informed the source in the first place that target was the holder of the RIO. So everything's got the trust basis of the router.
No, but is it only triggered because there was a redirect situation, or
that's one example of the way it gets triggered? Yes.
Well, not one example. Security is the worst example, not the best one.
Right. Okay.
Lorenzo Colleghi, I think I've seen this 3 times. Have you fixed the problem where the router can't deprecate anything anymore? In the sense that, router says, okay, here's a, whatever, 64 on link. And then you parcel off whatever it is that you want to parcel off, a 96, 104, and you give it to some other node. And how does the main router renumber that link?
So the router is telling the source that a target is a holder of a prefix. And
how do I tell it that it doesn't hold that prefix anymore?
The router can send back another redirect message with a lifetime. The router can send a router advertisement with a lifetime of 0 on that prefix. It's not specified in the spec at this point, though.
Yeah, I mean, like, what do you wait to a lifetime of 0 for what prefix?
For the prefix that it referred earlier.
So it needs to keep state about all of them. Everything that it referred, if it wants to take it away, it has to. So how does that fit in one array? Yeah. When I refer, like, you're talking about 10,000 nodes, right? I delegate 10,000 whatever /96s to all my airplanes, and now I have to renumber that. I have to send 10,000 RAs or 10,000 PIOs in the RA. This is why you need a routing protocol, right? You need something that's up to date and it can be updated in both directions. Right now you have a unidirectional update. You can send traffic away and delegate it to someone else, but you can never claw it back. And the security implications, I think, the other side of that coin. I think it's very tightly coupled.
Well, the router is your security trust basis for the link.
I get it, but it can't take anything away. It can only give stuff away, and it can't take it back.
It can take it back by sending a lifetime of 0.
But it has to do that for every subprefix that it delegated?
The router is the one that was involved in the prefix delegation in the first place.
Okay, that's right. Say that I'm the router. I delegate 10,000 subprefixes on this link. Do I have to claw back all 10,000 of them individually?
Well, how does it work for prefix delegation in general when you don't have this in place? The router is going to have to renumber the nodes that it sent the prefix delegations to, even if you don't have this mechanism.
Prefix delegation is a promise, right? It has a lease time, and there's only 2 parties involved. So if you do PD and you're the router on the link, right? If you get a packet, then you send it back to the person that you delegated it to, and at all times you're in control of that forwarding. If that lease times out, or if you've decided it's no longer valid or whatever, you just don't forward the packet back. But here you're telling 2 intermediaries that they can talk to each other, but you're authoritative for the thing for the addresses that they're using.
Right.
So,
So what would happen then, Lorenzo, is that the target that was the one that got redirected to would realize that his prefix delegation is no longer valid, and he could then send an unsolicited neighbor advertisement back to the source and say,
how does it know which source has received its redirect? Does it keep the state on all redirects it's received?
It does keep track of who was redirected to it.
That seems like a crippling scalability issue, though.
No, not necessarily. You're not going to have millions of correspondence for each node. You'll only have a few correspondence for each node, and they'll remember that they got a neighbor solicitation from the correspondence.
Okay, then you need an applicability statement saying how this is going to scale and what the parameters are. Because if you talked about 10,000 airplanes, then this doesn't scale to that.
But they're not all going to be talking to each other at the same time.
You say, but you need to say this in an applicability statement.
That's a fair statement.
Yeah.
I get that.
I would also want to note that, like, case number 1 doesn't apply, right? Because nodes don't receive prefix delegations. Case number 2,
not yet.
Okay, it doesn't apply today. Okay, case number 2 doesn't apply today because
yes, it does.
Well,
yes, it
almost certainly the VPN provider is going to want to see that packet. They're like, I would bet whatever amount of money that if you have a VPN and 2 devices are on the same VPN, the VPN operator is not going to want those 2 to talk peer-to-peer on the local link.
I'm doing this in Boeing right now. The enterprise.
Then you have a security problem.
No, I don't.
Okay, or maybe in your security environment this is acceptable, but in general for VPNs everything is hub and spoke. So anyway, maybe we just need an applicability statement, because I think this draft waves its hands over like some pretty fundamental reliability and security issues. And if we want to publish this, we have to be very explicit about how it scales, what the security properties are, and so on.
Okay.
It's nice to be able to define a mechanism, but we need to think about all the implications.
Sure, appreciate it.
Yeah. So Does the draft currently say there's basically a lease time or a lifetime on these things when they're signed?
Route information options have lifetimes, and the lifetime would be the amount of time that you would trust this route, you'd accept this route. And when the lifetime expires, then the route goes away.
So when it expires, the information will go away and it'll send to the original place and get redirected again?
Yeah, yeah.
Okay. Yeah, that's working. It might be a bit suboptimal, but...
Eric Klein, I think I actually may have had my question answered. I just missed it. When a redirect occurs, is the thing that has a prefix delegated to it that will respond with an NA with an RIO in it, is it also able to send an RA on this link?
No, only
Not
the
at all.
router can send the RAs on the link.
So it can't even send a 0 default lifetime. But
Oh, if you could send that in an NA, you could send a neighbor advertisement message with the RIO message and set the lifetime to 0. So the target can always invalidate the route that it previously promised to the source.
Mhm. So there's some other routing relationship between the router and the thing that you said it's the thing that's delegating the routes.
It's classic redirection. The source gets redirected to the target. The source says to the target, please give me this route. And the target comes back and says, here's the route. And at a later time, the target can come up and say that you can't use that route anymore.
Right, and the validation is that it was solicited, but also that it's binary identical to the thing that it got told by the router, by the RA.
Right.
Yeah. Right. I see. Thank you. Yeah.
Okay. So I had also a couple of comments. So the purpose of this, as I understand it, is to allow the nodes to talk to each other on the same link.
Yeah.
But most of the things you list up here at the top, like Wi-Fi, does not allow nodes to talk to each other directly, or cellular. It all goes up to an access point or a switch or something.
At layer 2, yes. But at layer 3, we could avoid having to go through a layer 3 router.
Okay, but so I basically think the things like Wi-Fi and the kind of things you talk about here don't support the kind of communication that you're talking about. So I can believe that there might be other types of non-broadcast multiple access networks that will do this, but I think the ones you're citing here don't really do that, and they don't want to do that.
I won't argue the point with you, Bob, if you can agree that there's a possibility for large NVMe links where they would be able
Well,
to.
so I think if there are, you should talk about them specifically and explain what they are, because I don't know what they are, and so it's hard to judge this. Another comment is, I think what you're calling the Type D host is what I would call a router, because it forwards packets not addressed to itself. So I'm not sure I agree with the notion of a new class of hosts.
I think Class C hosts, Type C hosts, are borderline the same consideration. But when I'm talking about a Type D host, I'm thinking about multi-addressing in the spirit of 7934, which would say that you get a prefix only for addressing within yourself. You don't have any networks downstream of yourself. In that case, it's very host-like.
Right, but the picture you shows another link behind the node with things on that link, and that's a router.
I can add other diagrams that would show it to be more host-like. My other draft also has the diagrams already in it.
Last comment, Lorenzo?
Oh, yeah, I just wanted to say in the first case, there is no gain because in any large network, the cost of sending the packet peer-to-peer and the cost of sending it through the AP is pretty much identical.
Except
yes,
that
not always, only about 99% of the time.
Yeah, I agree that it would go from A to B through the access point at layer 2, but it wouldn't have to pop up to a layer 3 router at the access point. It's the same box, but it's a layer. It's a protocol layer that you don't have to go through.
Okay, I think we have to continue this one on the list. And how many people have read this document? Right. So please, please read it and comment on the list. Thanks, Brent. Thank you. So let's see. The last presentation note today. Lynn, please. you have 10 minutes.
Yes. I think I may not have time to complete the presentation. I just try to give the high-level summary of what we are doing. So this is a new draft, which is informational, and it's about our recent research for the transport to support ultra-high bandwidth and ultra-low latency. And next page, please. So our motivation is that the current network is it's just based on the best effort IP service, and it influences transport a lot. But we want to give a IP level service with kind of QoS, then to see what transport can behavior. And the basic idea is that based on our analysis, there's a lot of background analysis in the draft. I think if you are interested, you can go details. And we try to have more involvement of network device for transport service. And also we want to have simpler protocols because we know that ISVP is kind of not deployed. So we have this kind of design targets. And some targets is just for the deployability, and some targets is for the network neutrality, such as the last one is for network neutrality. So because it's cover a lot of area, I don't want to go details. Next page, please. So conceptually, we try to introduce a new sublayer to support the transport. We call this transport control. And what we want for this transport control is that first is to in-band signaling. In-band signaling is not new. It was proposed 10 years ago by John Harper from Cisco. That time it come out TCP quick solution, but we think that's not good enough for the real QoS support for transport. We just want to go further. And this layer can also provide the congestion control, because right now the congestion control is based on the host only. We think the network device can be involved a lot, because the network device know what exactly happened for the congestion before it just use the packet loss or delay to detect or guess the status of congestion for network. Next is for the path OAM, because right now a lot of information for the IP path about the hop number, latency, and the bandwidth is not known to end user or application. With a device involvement, we can get detailed information of this. And this information is very useful for the application to decide how much amount of data it can send. Critically is the feasibility, because the concept was there, but before the hardware is not good enough to support this. So our work is try to test the network processor to see if it can do this, especially the in-band signaling. Network processor is combine the both advantage of ASIC and CPU, so it can do the packet forwarding very fast, and also do some general simple work for like CPU, like the hashing and read write, and even can have a very small database. So that's why the NPU can help us a lot for this purpose. Next page. So this is the major characteristics of the control plane and data plane. I don't go to detail, but in simple is that for control plane, we want to use the data packet to carry the control information. Then every node can intercept that information to program the QoS. Of course, those nodes are selective. Not every node has to do that. And for data plane, it not only provides the QoS support, also it can keep the QoS state. Means that if there's no data packet coming to refresh or use that QoS state, that state will be erased and the resource will be released. So by this idea, then our control protocol will be very simple, which means that we don't need a centralized controller card to control this. Then all control process or work can be distributed on the line card or NPU, because NPU is not like the control CPU is only one or two, but the NPU is very likely is port based. So we actually distribute the all control work to all each MPU. So the scalability will be much better. Next page. So here is a solution for IPv6. It's very simple because IPv6 provide very powerful extension. Right now we are using two extensions for this. One is a hop-by-hop extension, which for the programming for the node. And the next extension is a destination extension, which is used for the programming state report to source. And I think for this community, we only care about IPv6, so I don't want to go to IPv4. IPv4 has a lot of problems. So next page. So here is how it works. Very simple, that every data packet can be TCP SYN or TCP data. When they send to one direction, it can carry the single information which was inserted by application or system, is by host. Then those information will be intercepted by the, we call that hop-by-hop aware router. It will be intercepted by those routers and the program hardware. The hardware programming state will be returned to the update to the extension header, and the extension header will accumulate all states of programming hop by hop, then send to the destination. Then the destination will convert all those programming states to destination extension header. Then that information will send to the source. Source will know that what is the programming state, then can make decision accordingly. For example, if they know the bandwidth is not enough, they can either lower requirement of bandwidth or use other protocol to select different IP paths. Because right now this is using try to use the path that IP forwarding decided. So luckily in our real system, the node which required to be hop by hop aware is not too much, because for the transport point of view, if the link or port is bandwidth is enough, no matter how much you require, the bandwidth will be guaranteed. We only have to care about those routers which likely be congested or aggregate the traffic. Then for those routers, we can configure to be the hop-by-hop aware. Then those routers will program the QoS accordingly. So below the picture is that for the real network, normally we have a couple of congestion point which are likely to be programmed for QoS if you want to have a kind of guaranteed service for flow. So next page. The most concerned problem is the scalability of performance. In our experimental, we do test this very thoroughly. So right now, for the industry, the normal CPU is the highest processing power is about 200 gig. So let's assume that a processing power of CPU is 100 gig. Then because this technology is not used for the application which is not sensitive to the bandwidth shortage or large latency, this technology is only used for the application which require a lot of bandwidth and very sensitive to the packet loss. So we can easily assume that if we divide the resource of 100 gig to be 50% for new session, then if each session needs 100 meg, then we only need to support 500 sessions per MPU. This is really feasible. And also for performance, because right now the each MPU intercepts the signaling message and the program QoS in our test is about a single digit millisecond, less than sometimes less than 1 millisecond. But let's assume it's a 10 millisecond. If it's a 32 hop, it's only 320 milliseconds. 32 hop is a lot for the application which require ultra high bandwidth and ultra low latency. Because right now, with the improvement, with the development of the 5G and beyond, they require the content provider to be close to the access network as close as possible. So 32 hop is a lot. Basically, the scalability and the performance is kind of acceptable from our experiment. Next page. So because for this draft, it covers the IPv6 and also transport. So we have another presentation in Friday for detailed result of the congestion control, and also it has other areas I list in the draft as other issues. If you are interested, please read it. And this work also in progress in the ETC NGP group. So there we will have a much more detailed discussion there. After this Q&A, we have a lot of supporting slides. If you are interested, just read it. Your feedback is very appreciated. Thank you.
One question and then...
Oh, actually, yeah. I got 4 questions. One was already answered because I don't think it's only about it's nothing about IPv6 here. That's about transport protocol, but you answered it just now. On the draft, you talk about IPv4 in 6 months. That's kind of weird.
Yeah.
And I read it, and 3/4 of the draft is about QoS, which is a network processor, which I don't think needs to be there in a 6-month draft. It's only the last quarter which explained that you want to use some extension headers, which is fine. So I would recommend to remove the introduction, which is longer than the rest. And the last point, you need to specify that as you're using extension header, it will not go outside of an administrative domain.
Yeah, right now, actually, in my draft, because this is a big area, I just say that for this draft, we only focus in a single domain. But from technology point of view, there's no problem to extend it. Of course, for this draft, we only limit it in one domain. Yes, closed domain.
Okay, thank you.
Yeah, thank you.
Yeah, so thank you. We're out of time, so okay. Thank you very much. So, I mean, the discussions we've had on this is I don't think 6MAN is going to own this work. I think it belongs more in something like transport. There may be some packet formats for us to look at, but the architecture is proposing, I think, is... Sorry. Oh, sorry. Conclusion is that this work probably is not going to be owned here. It's much, I think, transport is a better place for it. There may be some packet formats we look at later, but the QoS architecture is proposing is not in scope for here. So I think that's it. We finished on time. We'll see you in London.